Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of PTSP, probability theory and stochastic process problem. The given example is prove the following identities. First bit is probability of A bar is equal to 1 minus probability of A, and second bit for any two events capital A and capital B, probability of A bar intersection B bar is equal probability of B minus probability of A intersection B, and B bit probability of A intersection B bar is equal probability of A minus probability of A intersection B, and third bit is if B is the subset of A, then probability of A intersection B bar is equal probability of A minus probability of B. And this is the given example. Now coming to the solution, first bit solution. So we know that the events capital A and A bar. A is the event and A bar is the complement of the event. The events A and A bar are the two mutually exclusive events or disjoint events. That is A union A bar is equal to universal set. Two events are said to be mutually exclusive. That is A union A bar is universal set. That is A union A bar is equal to capital S. So take the probability on both sides. Probability of LHS term is equal to probability of RHS term. If the probability of occurrence of event is 1, then it is known as sure event. So that is probability of S is equal to 1. So probability of A union A bar is equal to 1. So using addition theorem or the joint probability theorem, so probability of A union A bar is probability of A plus probability of A bar minus probability of A intersection A bar is equal to 1. Now here events A and A bar are mutually exclusive events. Probability of A intersection A bar is 0. Probability of A intersection A bar is 0. So therefore from this equation, probability of A plus probability of A bar, probability of A intersection A bar is 0 is equal to 1. So this probability of A is coming to the RHS side. We have probability of A bar is equal 1 minus probability of A. This is the first bit solution. And second bit, there are two bits, and second bit A bit solution is, now here the events are A bar intersection B and A intersection B bar are two events. The two events are mutually exclusive events. That is intersection of A bar intersection B and intersection B is equal to 0. So events A bar intersection B bar and A intersection B bar are mutually exclusive events. Intersection of those two events is 0. Probability of intersection of those two events is 0. So therefore, now here these two events are mutual exclusive events. So union of these two events is B. So that is A bar intersection B union A intersection B is equal to B. So in this equation, take the probability on both sides. Probability of LHS term is equal to probability of RHS term. On LHS side, using joint probability condition, probability of this event union this event, and probability of A union B is probability of A plus probability of B minus probability of A intersection B. That is the joint probability. So using that joint probability condition, this equation of LHS term is probability of A bar intersection B plus probability of A intersection B minus probability of A intersection B intersection A intersection B. Probability of A bar intersection B intersection A intersection B is equal to RHS term. So now here these two events are mutually exclusive events. So intersection of these two events is 0. So therefore probability of A bar intersection B plus probability of A intersection B is equal to probability of B. So therefore probability of A bar intersection B is equal, this term is going to the RHS side. We have probability of B minus probability of A intersection B. So this is the first bit of the A bit of the second bit solution, and B bit of the second bit solution is similarly events A intersection B bar and A intersection B are mutually exclusive events. So the intersection of these two events is 0. That is probability of A intersection B bar intersection A intersection B is equal to 0. So now here these two events are mutually exclusive events. So union of these two events is equal to event A. So that is A intersection B bar union A intersection B is equal to A. So take the probability on both sides. So probability of LHS term is equal to probability of RHS term. So using using joint probability. So the LHS term is probability of A intersection B bar plus probability of A intersection B minus probability of intersection of A intersection B bar and A intersection B. So that is, so these two events are mutual exclusive events. Intersection of these two events is 0. So LHS term of third term is 0. Therefore, probability of A intersection B bar plus probability of A intersection B is equal to probability of A. So therefore, this term is going to the RHS side. We have probability of A intersection B bar is equal probability of A minus probability of A intersection B. This is the B bit of the second bit. And third bit solution, when B is the subset of A, the events B and A intersection B bar are mutually exclusive events. The intersection of these two events is 0. Probability of intersection of these two events is 0. That is, probability of B intersection A intersection B bar is 0. So these two events are mutually exclusive events. Events of these two events is equal to A. That is, B union A intersection B bar is equal to A. So take the probability on both sides. Probability of LHS term is equal to probability of RHS term. So therefore, probability of B using joint probability LHS term of this equation is probability of B plus probability of A intersection B bar minus probability of intersection of B and A intersection B bar. So B and A intersection B bar are mutually exclusive events. Intersection of probability of these two events is 0. So third term of this equation is 0. Therefore, probability of B plus probability of A intersection B bar is equal to probability of A. Therefore, this probability of B is going to the RHS side. We have probability of A intersection B bar is equal to probability of A minus probability of B.